Okay, so we're looking for solutions to this trigonometric equation. It says that the sine of t is equal to the sine of 2t, and we have to find values of t for which this is true. And we're only looking for values from 0 to 360 degrees. So the key to this question is to spot that we're not really going to be able to work with a sine t on one side and a sine 2t on the other side. We wouldn't be able to collect those together or to kind of simplify this down further without changing the sine of 2t, which is a double angle, using one of the ratios or one of the formulas that's in the formula book. So the formula we're going to use is we're going to change the sine of 2t using the formula the sine of 2a is equal to 2 sine a cos a, which means that the sine of t is equal to 2 sine t cos t. And now we have an equation where we just have this single angle t in the equation rather than this double angle 2t. A lot of people might look at the sine t on the left and the sine t on the right and think, oh, we could divide both sides by sine t and that would get rid of the sine t and we'd have a much more simplified equation, but we're not allowed to do that. And the reason we're not allowed to do that is it is possible that the sine of t could be equal to 0, and we're not allowed to divide both sides by 0 in maths, and the reason is we're not allowed to divide anything by 0 in maths because it's undefined. So think of that as like this quadratic equation, x squared equals 8x. So likewise, we wouldn't be allowed to come along in this equation and just cancel or divide both sides by x to get x equals 8, because we would miss a solution, and the solution we'd miss would be the solution x equal 0. Clearly 0 squared, which is 0, is equal to 8 by 0, which is 0. So dividing both sides by x, that'll discount the solution x equals 0. So what we should do instead, when we have an equation like that, is we should bring the x terms to the left hand side, so x squared minus 8x equals 0. We're going to factor out the x, so x on x minus 8 equals 0, and we'll get our two solutions. We let x equal 0, and we let x minus 8 equal 0, which means that x equals 8. So we're going to apply this reasoning to the equation that we have here, and what we're going to do is we're going to collect all the terms on one side. So if I leave a 0 on the left and I subtract a sine t from both sides, I get 0 equals 2 sine of t cos of t minus the sine of t. And I'm just going to reverse the order of this so that the 0 is on the right hand side instead. So it looks like this. I can now factor out the sine t, so I'm not dividing everything by sine t, I'm factoring it out. And the reason I do that is because then sine of t could be equal to 0, and we'll get our solutions from that. And then likewise we have 2 cos t minus 1 could be equal to 0, in which case 2 cos t is equal to 1 and the cos of t equals a half. So essentially what we've done is we've taken this quite complex trigonometric equation at the start, and by using an identity we've created two separate trigonometric equations, which are quite easy to solve individually. So let's have a look at how we might solve each of these. So I'm going to solve sine t equals 0 first. If you think about the sine of t equals 0, so what's the value of t that would give 0? We're going to use a unit circle in a second, but think about the graph of sine of t. The sine of t goes through 0, 0, so it goes up, and then it comes down, and it goes up again. And we know that the period of this is 2 pi, so this is pi, and this is 0. And we can see the three values that give 0. So t equals 0 here, that gives 0. T equals pi, or if we use degrees, we have 180 degrees, that gives 0. And then t equals 2 pi, or 360 degrees, that gives 0. So there are three solutions, 0, 180, 360, they're all in the domain 0 to 360 degrees. And so there are three of our solutions. Now generally we don't draw a graph to find those solutions. If we have sine and cos ratios equal to 0, 1 or minus 1, the handiest way to figure out what the angles are is to draw the unit circle. So here's our unit circle where we are going to label the points 1, 0, we'll first put in the angles. So we have 0, 90 degrees, 180 degrees, 270 degrees, and back to 360. And then if we label these points, this point here on the unit circle is the point 1, 0. This point up here on the unit circle is the point 0, 1. This point on the unit circle is minus 1, 0. And then this point is 0, minus 1. So with that in mind, what are the values of t that make the sine of t equal to 0? Well, if we think about each of the points as being cosine, 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 we can see that sine is 0 at 0 degrees, sine is 0 at 180 degrees, and then sine is 0 again at 360 degrees. So that's the handiest method to find the angles. Doing the unit circle, labeling the points 1, 0, 0, 1, minus 1, 0, 0, minus 1, and then realizing that those points are cosine, 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 cosine. And we can see that sine is 0 for those three values, 0, 180, and 360 degrees. For 2 cos t minus 1 equals 0, well, we've looked at that already. That's 2 cos t is equal to 1, so the cos of t is equal to a half. We're going to use the cast method. So the cast method is a method first for figuring which of these quadrants is the cos ratio going to be positive. We have cos t is equal to positive a half, so let's put in our A, C, T, and S. The cos ratio is positive in the first and the fourth quadrants. So we draw two little lines there just to roughly show which quadrants that the solution angles are going to be in. The next thing we do is we find the reference angle. So to find the reference angle, we find the cos inverse of a half, and we make sure that it's plus a half. If this was cos t equals minus a half, the reference angle is still the positive version of the ratio. So cos inverse a half is equal to 60 degrees. So we have 60 degrees up here, and then if we work back 60 degrees from 360, we have 300 degrees. And they're the final two solutions to this trigonometric equation. So our 5 solutions in the end are 0, 60, 180, 300, and 360. And if we wanted to go and test any of these, we could go back to the original equation, and the 0 one is obvious. The sine of 0 is equal to the sine of 2 times 0, which is 0. That's obviously true. If we looked at 60, the sine of 60 is equal to the sine of 2 by 60, which is 120. That's true, and it'll also be true for 180, 300, and 360. Now, there's infinite more solutions. Like if we were to add values 360 degrees to all of these angles and continue that forever, they would also be solutions to this original equation, but we're only looking for solutions from 0 to 360 degrees.